This is a program that's intended to introduce students to a wide range of analytical tools and computational tools, and as well as the whole environment of applications in remote sensing. The first part of it is getting everybody up to speed with the kind of fundamental principles that everybody needs, so analytical tools and methods, whilst introducing them to the sort of fundamental principles of remote sensing, so the kind of the physics, the engineering, the background of how we put instruments in space and on UAVs, and how we do measurements on the ground, and how we use mobile phones and acoustic measurements and all of these different kinds of new technologies to measure the environment around us and use that to solve important scientific, environmental and commercial problems. And we have our core modules, which include things like methods background, so getting all the students up to speed with some of the kind of basic statistics and mathematical tools that they're going to need, as well as scientific computing, so that people can read in data, so they can analyse it and produce scientific plots and get information out of all kinds of quantitative data. Options modules, which cover a very wide range of things, from things like close range measurement through to the carbon cycle and climate, using geographical information systems for looking at kind of coastal modelling and ocean environments, thinking about the atmosphere and thinking about forests and carbon. We have lectures and seminars, and we have quite a highly involved computer practical element, lab-based, using pieces of equipment and using different data sources. There'll be seminars involved, and we have some traditional examination-based assessment, essays and coursework, collaborative coursework that can involve things like producing reports. It can involve blogs. We have poster-based assessments, verbal presentation-based assessment, through to the dissertation itself. We have students doing a wide range of things in dissertations, and for students who do really good pieces of work on the dissertations, we quite often have people go on to publish things in high-level journals, looking at redwood trees growing in the UK and the history of redwoods in the UK and how fast they're growing and how much carbon they're taking up and how rapidly they're growing in comparison to other trees and woodlands that have been planted and managed in the UK. Students using a combination of airborne and satellite data, looking at the status of urban forests and the kind of rate and lot of gain and loss of trees in urban areas, and how that affects the urban lived environment. People who've come through our master's programme are now professors in remote sensing and environmental modelling and mapping. People going into government, people going into NGOs and charities using geospatial data mapping. A lot of people going into to the geospatial data commercial side of things. ESA, the European Space Agency and NASA, UK government, overseas governments, computing-based stuff and system admin and IT and financial modelling and working in the finance sector. So a very wide range.